So I'm JC, last name Lopez. History with Ceph goes very, very far. I'm an ex-think tank, so Red Hat acquisition, IBM acquisition, leave Red Hat, come back to IBM, and I'm back in business. I'm still doing Fusion and Ceph basically. It's just like it doesn't want to go away from me. Anyway, I love it, so it's all good. So it's just to discuss about data security and storage, hardening in Rook and Ceph. I'm going to try to see over there. My eyes are just like, I'm like Yuval. It's just like, we're just getting old. So sorry for the delays in the reading with the binoculars over there. So Ceph. So first of all, so you're here, so you're all familiar with Ceph, so there's no need to really introduce. But Ceph was presented and is still, I believe, really the future of storage. It does fire block an object, so that's pretty cool. And even today, although I worked back in the days, with standalone clusters mainly, now we see that there's more and more presence of Ceph as a software and as a solution in Kubernetes and OpenShift environments, which really proves that Ceph, from its inception, was designed to be extremely flexible, and it just adapted itself to this new way of doing in a pretty easy way. So highly resilient, highly available, extremely scalable, and it goes with a scale-out model. That's all the strength of Ceph in a nutshell. So Rook was it's another project that was incubated through the CNCF, and the idea was to adapt and use the operator model so that we could let Rook just deploy a Ceph cluster inside a Kubernetes or OpenShift environment. And Rook as an operator has been reused for OpenShift Data Foundation, and now at IBM it's called Fusion Data Foundation. So we just keep rebranding, right? It's still the same stuff, the cool Ceph inside. It just changes name, so that's wonderful. And so it's basically Ceph based. So it's what I always say is just like one of the differences if you want to think about Rook versus Ceph. Ceph now these days, if we go back in history, we had MKSF for the old days, then we had Ceph deployed, then we had Ceph Ansible, and now we have Ceph ADM. So basically Rook is a Ceph deployed through Rook. And it's the exact same thing we use when we do Ceph ADM, so we use containers. So again, Rook was perfectly designed to actually adapt to that model. So it's basically storage on top of compute. So it's a hyper-converged model, although you have different options so that you can actually use Rook to deploy what we call an external mode. So you can attach yourself, your Kubernetes cluster or OpenShift cluster to an external Ceph cluster. So extremely flexible, and it will take care of everything and reconcile whatever CRs you have in there so that we will monitor the state of the cluster, and we will automate day one and day two operations, which is pretty important in orchestrated environment with containers. So resource management through the operator framework, and we take care of the upgrade, the rollback, whatever we need to do. You have automation to remove and replace OSDs. You can very easily through the CR managed by Rook to actually scale your cluster. So you can just scale up on a node by adding some OSDs on a node, or you can actually scale out and consume new nodes with new OSDs on them. So it's extremely flexible. So one of the things when we think about security, and it's always the same, whether we're talking storage or we're talking compute and we're talking applications, we always get back to the same things, which is the threat models and what threats do we recognize and what threats do we want to look after. So some of the famous one, nation states, organized crime, obviously. I will take you an anecdote about that. Hacker groups, motivated individuals, privileged insiders, and script kiddies. So when we're talking about organized crime, I just had a friend about 2 months ago. He's an age gentleman, this is like it's 76, if I remember, and he got a call from Microsoft support. Guess what happened? So, it can happen to everyone. So when we say organized crime, a lot of people say, it doesn't happen. Well, guess what? It's a very, very present threat, actually. So when we think about what we do with with an IT environment, so if we think about the way Ceph is going to be present in that environment, we're going to have the public zone. So when we say public zone, we're not talking about the Ceph public network, what we call the regular network where the actual clients come into the Ceph cluster. We're really talking about the point of access of terminals that are outside of the data center. That's what we call the public zone. Then we have the Ceph client zone. So imagine that you would have a client that would get to a Rails gateway. Then the Rails gateway would need to get to the Ceph cluster. It would do that over, the public network of the Ceph cluster. So that's that Ceph client zone that we call. And then you will have the storage access zone, and that's going to be really where the traffic is going to go into the Ceph cluster. So that in the end, what's going to happen is that depending on what you're going to do in terms of IO requests that you've asked, you may go over the Ceph cluster zone, which is the cluster network where the traffic is going to take place in case you have a write operation. So we're going to need to replicate the operation that you do between multiple OSDs, and that will go over the Ceph cluster zone. So that's the cluster network parameter that you have in Ceph. So if we make a diagram, it's not easy to speak, too far from that. Just going to raise the voice. So the public zone, so we represent all of the nodes that we have. So you have the client nodes, the RGW nodes, the CephFS nodes, the RBD nodes, and we represented every single type of network with a different color. So the public zone is somewhere outside of here, but you have the Ceph client security zone, which is the client network. You have the public network, and you have the cluster network where we're going to do the replication between the OSDs. So that's like a schematic representation of all these network zones that we've just discussed. So product security. IBM does perform security activities across the life cycle of every release that we issue. And the goal is always to reduce the risk and to improve security in both Ceph and Rook. No difference. So for those who are not familiar with the acronym, so SDL, that is on the first line, I made like an equivalence, which is Secure Development Lifecycle, for those who are not familiar with the acronym. So what is important is that we are always looking for improvements. So not only and we're going to see that after that we audit the code that we have, and we always try to make sure that we're not vulnerable. We always try to make the code better, to make the software better, and that includes actually doing some pen testing so that we can just run some specific tests and see exactly what is the exposure level that we have with the software. So many new things will be coming through that collaboration, and one of the other slides we have, actually IBM is way more stringent when it comes down to security because of the history they have with some specific markets. So hopefully we'll do an even better job when it comes down to security of Ceph and Rook than what we used to do when we were Red Hat. So life will tell, but for sure this is something that is extremely important, and that comes back in many calls with engineering regarding security. So the IBM PSIRT, and again, I just put the acronym, so that's the Product Security Incident Response that is quoted in there. So we will continue to manifest, document all the open source material that we have in Ceph. As you know, Ceph leverages a lot of libraries, open source libraries that we have, so we are extremely cautious, and we pay attention to the pieces we use and that we bring into Ceph because it's basically part of what we ship, when we ship Ceph. So we cannot say we just look at our code and, basta, it's just like it's gone, it's behind us. We need to actually be extremely careful and pay attention to what we use and what we leverage in terms of open source libraries that we use in Ceph. So we'll be onboarding with the IBM PSIRT so that we will use the toolings that they have, which is way more extensive, as I was saying. And the idea is that we may found new vulnerabilities than before. And obviously, we don't intend to let those vulnerabilities that we will find, in the code. So the whole idea of benefiting from all of the existing PSIRT process that they have at IBM will help us improve the level of security of what we ship when we ship Ceph, whether it's in the Ceph hook through the upstream projects or the downstream projects, no difference, right? It's not only, remember that, whether you think Ceph, you think Rook, it's always upstream first, it's always community. When we build a downstream product, it's the same code. So everyone will benefit, whether it's the upstream community or it's the downstream customers. So we'll continue to review everything that is existing. We'll have regular security updates. We'll improve code security. And we will eventually follow IBM standards to fix vulnerabilities because they have their own processes on how things should go and how things should get fixed. So we will have to learn from these processes. We're just new, after all. So I rejoined IBM back on July 18th last year. All of these guys over here that you see, they rejoined, I think the official date was January 1st, right? So we still have to learn. I'm still learning. I always tell my IBM colleagues I'm a newbie. It also gives me an excuse sometimes. And it's new processes to learn. So as I was saying, most of the time, the processes IBM has in terms of security is way more stringent than what we used to have when we were Red Hat. So it will be a benefit for both Ceph and Rook. So all the new work that is in the play, so all the CVE fixes will continue to be ported to upstream Ceph, no difference. Remember upstream first. We'll keep all the versions of Ceph, and remember that Red Hat will keep and will OEM Ceph and ODF, basically the two products that they used to have at Red Hat, will now basically be OEM of IBM products. So we basically swapped the go-to-market strategy. Before it was Red Hat market first, and IBM was OEMing Red Hat products, and now it will be the opposite. So it will be IBM products, and Red Hat will OEM the IBM products. So new collaboration, new challenges, lots of goals. Fingers crossed, we'll do great things, really. If you want to learn and you want to know more, so you can reach out to me, you can reach out to Federico. Anyone is reachable. And if you are concerned by security, and we'll go into more details about what is in the security and what we use, and what are the tools that we can leverage to have a more secure environment, we go into that after. So one of the first things you can do when it comes down to security, obviously encryption and key management. So one of the features, at-rest encryption. So you can enable that at the OSD level, what we call cluster level data at-rest encryption. You have different ways to do it. So you can have self-managed keys directly. So we store the keys in the monitor database. Or now, with the later versions, when you do Rook Ceph, you can actually use an external key management system to actually store the keys. We still do not support rotating the keys, just so you know. But basically, it's just the idea is always to try to keep the keys away from where the data is. That's always the main goal. So one note on that, a lot of people are always concerned about the minimal size of a Ceph cluster. And because they, for whatever reason, let's say they want to save money, so they always say, just I'm going to put the monitors, the OSDs, the MDS, and the Rados gateway, everybody on the same node, right? We have 3 nodes. So the idea and the love of especially salesmen, right? Because they want to sell cheap there. just like cheap people. The problem is that when you do self-managed keys in a Ceph cluster to do data at rest encryption, where do we store the keys? In the monitor, which means that if someone was to steal, imagine the worst case scenario was to be able to grab one of the nodes, what does he have? It's only a 3-node cluster, so you know that you have a copy of all the data on one of the node, you have the keys, you have the data, you have everything you want. And second stuff about that, very, very old story that happened to me. People will tell you, security, we need to do this, we need to do that. Remember that one of the main threats when it comes down to security is like physical intrusion. And a lot of people forget that. I can tell you about some IT rooms where I entered, where I was not supposed to enter, just knocking at the door, pretending to be someone. And people always laugh. And I've tried that trick when I was a consultant, an external consultant for the French Treasury, actually. It works fantastic. Just knock at the door, pretend you bring coffee, you're in, right? So data at rest encryption, sure, you can do that. But remember, separate the keys. So if you do not use an external key manager, prefer deploying the monitors on separate nodes for safety reasons, right? Now, object gateway, you can also do encryption in the Rados gateway. So it basically depends what you're after, the type of clusters you've deployed. There are many things that comes into the play. Obviously, if your data, you're already doing at-rest encryption at the cluster level, you don't really want to redo encryption at the Rados gateway level on top of something. So basically encrypt something that is going to be re-encrypted. Doesn't really make sense. So you choose. Other option, what you can do is that, remember that Crush is extremely flexible. So you can actually use separate nodes to do the Rados gateway OSDs because they're using slower drives, for example. And you could do a Rados gateway encryption on these OSDs, right? And deploy those OSDs non-encrypted because you can actually deploy in a Ceph cluster encrypted OSDs and non-encrypted OSDs. That's absolutely possible. So again, the flexibility of Ceph will let you adapt yourself and adapt the security you want to do in terms of at-rest encryption to the exact granularity that you want to meet what you need to meet in terms of security. So we do support external key management systems. So we do support HashiCorp Vault. We do support OpenStack Barbican. New to the playground is just like KBIP compatible key management systems. If I remember, we tested the Thales one, the French company that Thomson it used to be called. So as long as you are the encryption management system, just like adhere to the KMIP's standard, we haven't tested all of them, but it should work just fine. So in-transit encryption, so that's another very interesting point. Then it depends what you want to encrypt. So the first point is the messenger layer. So now we do have encryption in the messenger layer, so you can leverage that. If you do not use that, basically everything goes and travels from a Ceph X perspective, let's say Ceph native protocol. We're not talking Rados gateway. We're talking the Rados traffic. We just like traveling clear on the wire. So a lot of people will just say, wow, that's a no-no. Okay. However, you have to remember that enabling encryption at the messenger layer, just like we'll have a penalty, because we need to now do encryption for every single message that is going to transit over the wire. And it's always the race, right? I want security, but I want everything as fast as possible. And unfortunately, guess what? It's, the reality is it's always a matter of trade-off. So people have to be aware, do not lie, and go to your boss and to the end user, says, we can do it, but it will have a performance penalty. So all data at rest will be encrypted. Remember, this is what goes over the wire. So if you do OSD, if you do messenger layer level encryption, not only you will encrypt at rest, but the dialogue between, so the Ceph client and the primary OSD will be encrypted, but also the traffic between the primary OSD and the secondary OSDs will also be encrypted. So you can really encrypt end-to-end. If you think about it, including storing all of the data at rest encrypted, that's something that is doable. Something that always puzzled a lot of my IBM colleagues. We can deploy Ceph and we can deploy ODF, Rogue Ceph, on FIPS-enabled servers. So RHEL, we actually leverage the certification from RHEL when it comes down to FIPS 140-2. So it's pretty common, and I've deployed through my career, even before we got the FIPS 140-2 certification officially, like 4 years ago, something like that. And it's just working just fine, and it's just like completely functional. And at least you know that when you have a federal customer, especially in North America, that a question that will come right away, just like in the next 30 seconds after you start the call. And yes, we can do that. Another type of encryption you can do is that when you think about the object store, so you know that the Rados gateway and object storage is a very, very big use case around Ceph. So you can actually do, if it fits the use case in terms of security and the level of granularity that you want to have, you can do just like traffic over HTTPS and use TLS security so that you can actually have the traffic that flies from the S3 client to the Rados gateway to be encrypted, so that your data is actually protected really when it leaves the S3 client. So yes, there's the Rados gateway to the OSD, that's one part, but you also need to take care of what happens in case of S3 or this kind of client between the actual client, which is not an RBD client, it's not a CephFS client, it's an S3 client. So basically, an S3 client doesn't know about the Ceph cluster. He knows about the S3 endpoint. So you need to encrypt that portion when you think about security. TLS termination at the HA proxy, special case. So it's always a trade-off. So you can set HA proxy and you can set the Rados gateway so that you say that whatever traffic comes from HA proxy, you're going to be trusting it, even if it's not encrypted. So in terms of performance, you have a little gain, but some people will tell you, no, it's just like, we can do that. It has to be encrypted end-to-end. So you can do both. For many years, even when I was at Red Hat, the recommendation was always to terminate TLS at the HA proxy layer. That was the official recommendation, and that was actually just like written in the documentation. Network hygiene, remember firewalls. Yes, it's good to do encryption, whatever, but remember when I was telling you about physical intrusion, well, guess what? One of the main point of attacks is like weak firewalls. And one of the reason I mentioned that is that when people start deploying a cluster, very often they don't want to be bothered, Ceph ADM, we need to go from one node to another. It's just like, I want to make sure it's going to deploy the first time. What is the first thing most people do when they deploy a cluster? Just like switch off the firewalls, to shut down the firewalls. And guess what? You take a call, you need to go for dinner, for lunch, for whatever. You forgot that you basically shut down the firewall, and you forget to put it back together. Okay? Now, good news when it comes down to firewall, the latest versions, we actually ship Ceph service files for the firewalls. So we have one file that enables the firewall from the public network side, and another service file that just like takes care of the OSD to OSD traffic, so the port 6800 to 7300. So you can actually enable, so one is called Ceph, and the other one is Ceph Public or something like that. It has two different names, so you can actually do with the firewall CMD command, you can actually choose the service that you want to enable for the firewall. So control plane, so SSH, remember what we said. So it's always like, when people start talking about deployment, so remember we talked about the older versions of deployment tool, and one was Ceph Ansible. Well, one of the benefits of Ceph Ansible is that it was riding on top of Ansible. And when it comes down to host-to-host communication so that you can do a deployment, Ansible is an extremely rich tool. and you can really adapt yourself to a lot of configuration, passwordless sudo, sudo with password, SSH with password, SSH without password, omit the, just like bypass the key, the initial key checking. So Ceph Ansible was extremely rich, and Ceph ADM is like a newer tool. So it doesn't have all of the fun stuff that basically was built into Ansible. So that's something we're going to have to also learn to make better so that we have more flexibility and better security when it comes down with Ceph ADM. So Ceph ADM right now is relying on SSH to connect from one node to another. So yes, we create a key, but that's something that will come into the play if you're deploying a large cluster at a customer that is worried about security. That's a question you will have. You deploy your cluster, what kind of access is going to exist between the nodes, the node that is Ceph ADM. That's something that will come into the game. So remember that the SSH keys must be secured. Now, most of the Linux nodes anyway, and including RHEL and the others, you always get the warning if the permissions on your keys are just like way too wide and open, it will refuse to connect and it will tell you, no, you need to just like shut down and restrict the permissions on the keys so that you can connect to that other node. And port 22 is the one that we love to use. Management dashboard. So the dashboard is a very interesting case. I had a very long conversation with a colleague about 3 weeks ago. So the dashboard can run HTTP or HTTPS. So again, if you are concerned about security, you would not use the dashboard using HTTP. Why? Because the user and password to get access to the dashboard are going to just like shipping clear over the network. So you will want TLS, HTTPS, port 443, and make sure that you choose you will be prompted to change the password. If you want, you can change the password. You can pre-choose the password when you deploy. If you pre-choose the password, make sure that you use a secure password, not 123 or the usual thing that we all know, unless it's on your own laptop and you want to just like play for yourself. The other part that is going to be interesting about the dashboard is that, yes, you will use it as a Ceph administrator, but very often your boss or someone that wants to do monitoring of the environment will ask for access to the dashboard. And then comes into the game the type of customer where you are says, well, this is an external entry point into my Ceph zone. So the dashboard accepts HTTP or HTTPS when it comes in, but again, remember what we said about the MONs and the OSDs and everything on the same machine? Guess what? A lot of people put the dashboard on the same machine as the rest. So one of the things that you need to make sure, if you are in this case where you don't want any intrusion in your Ceph zone, you will separate the dashboard and put the dashboard. You do that very easily with Ceph ADM, and you put it into a specific zone and you deploy your dashboard on a separate machine. You can do that and never neglect, because that's an easy entry point. You can actually do SAML authorization. The manager, so that's the port that we use, the famous 6800 through 7300. That's your storage access zone that you need to make sure that when you do the firewall settings, you will have to enable that. So stuff that is root specific. So the CRDs can be used to control what you're going to do and how you're going to deploy your cluster. Example, client configuration, the certificates that you're going to use for the Rados gateway. But technically speaking, root itself is not really privileged, right? It's just like what you're going to put in the CR that is going to dictate what root is actually going to deploy, in your Kubernetes or OpenShift environment. So root does handle data at rest encryption. So when you create and there's an option where you say encrypted, and then you can do two types of encryption. So you can do self-managed keys, what we're saying with the keys that are stored into the monitors, or you can actually configure an external key management system such as HashiCorp, and root will handle that. And we've played with that since like Rook like antiquity almost. I think the first time I played with encryption at rest with Rook was like OCS. It was still OCS. I think it was 4.5, if I remember correctly. So that was somewhere around like early 2021 or late 2020, something like that. So we've been doing at-rest encryption, at least with the self-managed keys, and HashiCorp came after. So you can also set up the manager, the messenger parameters, so that you're going to enable in-flight encryption, messenger encryption level. So you can also manage that through Rook. Standard Kubernetes user permissions apply to persistent volumes. Rook does nothing right here, right? It's just like it deploys the cluster. After that, whatever the application, is going to use a PVC, claim a volume, you were going to allocate. So we're going to create either an RBD or a Ceph FSF volume. The app after that, and it's all Kubernetes, that is just like basically going to attach the actual PV to the pod, and the application itself inside the pod is just like going to use that volume. Rook has nothing to do with that part. So the CSI driver does support KMS, so you can actually do PV level encryption. So if some people say, my app is like super touchy, I don't want anyone else in case someone would get access to my PV that they couldn't be able to read it. So you can actually create a PV that will use an external key management system, and the keys for that PV will be stored in the external key management system. So someone without the keys, so without that proper access for that user, that app in that namespace, even if they were able to remount that PV into another namespace, they wouldn't be able to read it because they don't have access to the key. So CephX, it's something that is always touchy, and the reason it's touchy is that a lot of people, when it comes down to Ceph or to storage, are obsessed by performance. And most of the papers that have been written around Ceph performance, there's something that you always see in every single benchmark around Ceph: CephX disable. And very often what people do is say, well, that's what they used for that benchmark. That was the fastest thing on earth. So what should I do? Well, I'm not going to use CephX. Big mistake. CephX is the first line of defense of your Ceph cluster. So remember that if you don't have CephX, basically anyone can come into your cluster, and if he knows the Ceph CLI, he can do whatever he wants in your cluster. So CephX in a production cluster should always, always, always be enabled. Do not let that pass by. Very important. So as most of you know, if you do not specify a client name or client ID on the CLI, you are trying to connect to the cluster using the client.admin. So guess what? If you don't have the keyring and you do not distribute the keyring for the client.admin user, well, no one can get root privilege, and you need to store that client.admin keyring in a safe place. So remember what we said about encryption and data at rest. Guess what we put by default on the monitors? The client.admin keyring, okay? So guess what? Someone gets access to one of your nodes, he got everything that he needs to do everything he wants. So security is something that you just don't like go, it's easy. No. It's a lot of subtle details. It's just like when you do performance is a lot of iterations so that you can actually determine what you can do. Security is just like performance is a day-to-day job. It's not, I'm going to do a half-ass job, sorry to be crude. You have to take that from A to B and A to Z every single day. You have to check what you do. You have to check what people do. And we'll see that we have a few mechanisms and a few places where we trace what people are doing. So object gateway, S3 users, access key, secret keys. Someone that has an access key, explain to them that, their access key and the secret key is, their safety. If they don't want anyone to come and read the data, they better keep that, safe. Another thing that you have to explain to people that do A3, access key, secret key, fair enough. What is one of the most common things that people do when they start using A3? They set an ACL public, right? Because they don't want to be bothered. They don't want to remember the access key and the secret key, you know, the stuff that is super long, right? So they put everything ACL public, and then anyone comes. So you also have to be a cop and, you know, remind the people that if you are not integrated with an IDP or that whatever, just like access key, secret keys are just the thing to be taken care of. Yep.
So sorry, we have to wrap up. They have another program and we've gone over.
Okay. What time? Yeah, we started late though. So I'll share that. Well, sorry. I hope you enjoyed that. Thanks, Yuval, for the laptop. We'll share everything will be on, and the slides will be on. We're almost by the end anyway. Duck, duck. So we're 3 slides from the end.